Hello friends, in this video we are going to study the concept of subnetting. Why is the need for the going to subnetting? A question arises in our mind when we study about the concept of subnetting. Consider whole network of a class A. It consists of 2.24 hosts totally. If we try to manage this all hosts at a time, then it is not feasible as compared to the other networks. Hence, we divide this network into 4 different parts. 4 is a number tentative that we take in our example. If we divide the networks into 4 different parts, it creates a number of hosts also divided for each subnet, and the server also be different for each subnet. So it provides a security, and also the maintenance level increases. The difficulty of maintenance decreases. Hence, we prefer for the subnetting. Subnetting is nothing but the dividing the whole network into small networks. The advantages of subnetting is that decreasing the difficulty of maintenance and to increase the security. Whereas the disadvantages is that if we consider the whole network and we want to process the host process, it has 3 steps, consists 3 steps. First step is to identify the network, second is to identify the host, and third is to identify the process in that host. Whereas in subnet, the first step is to identify the network, second step is to identify the subnet, and third step is to identify the host, and fourth step is to identify the process in that host. For the more clear of the subnet concept, we will take an example. Consider the example of class C having network ID as 192.168.1.0. It consists of total 8 bits in its host ID. That is 2 power 8 minus 2 equal to 254 hosts are possible, where .0 is a network ID and .255 is direct broadcast IP address of this network. If we want to divide this network into 2 different subnets, we need only 1 bit. Consider this 1 bit. Therefore, this network can be divided into 2 parts having half of the bit, a network ID having 0 as the first bit and having 1 as the first. Therefore, the range of IP addresses host is as follows: 0. Here we have 0 in the subnet ID part. Here after that 7 zeros for the first host, again for the 1 for the last one for the second host, and so on. 1, 2, 3 and so on to 127 is possible for the all in the host ID. Therefore, the range of the host is 192.168.1.0 to 192.168.1.127. Whereas for the network, for starting with 1, we starts with 192.168.1.128 and ends with 192.168.1.255. Here 192.168.1.0 is the network ID of a whole network as well as the network ID of the subnet of consider this subnet as A and consider this subnet as B. And 192.168.1.127 is the direct broadcast IP address of a subnet A, whereas 192.168.1.128 is a network ID of subnet B, and 192.168.1.255 is the direct broadcast IP address of subnet B. If a packet of an IP address 192.168.1.0 comes from the outside, then where it goes, in a subnet A or to the whole network? This question arises after studying this much part of the subnetting. For this ambiguity, consider the following scenario. Here, this is an internal router and this is an external router from where the packet is coming to our network. Our network is divided into two parts of a class, subnet A and subnet B. The packet from where it is coming, that depends. Here 192.168.1.0 to 192.162.1.127 is network host ID of the subnet A, whereas 192.168.1.128 to 192.168.1.255 hosts are in subnet B. Therefore, if we send a packet of an IP address 192.168.1.0, then the package would prefer to which subnet, that is to whole network or to the subnet of a class, subnet of A. This depends upon the preference of the from where the packet is coming. If the packet is coming from the inside the network, that is 192.168.1.0 is coming inside the network of the whole network, then subnet, it will goes to the subnetting of A. Whereas if we consider the packet is coming from the outside, from this interface, therefore it will go, then it will prefer to the IP address of a whole network. This is all about subnetting. Now it's come from subnet mask. Subnet mask is of 32 bits. It consists of a network ID and subnet IDs. All ones of network ID and host ID, subnet IDs, combinedly prepared as a subnet mask. If the packet from the outside of an IP address 192.168.1.130 is coming, then how does the router knows where it to send for the network A and network B? As visually we can trace the path, but router does not know. For this we have a method. Here for a given R example, the subnet mask is as follows: 255.255.255.128. Here if we see that all network ID and the subnet IDs are 1, whereas all host IDs are 0. Hence the subnet mask for a given example is 255.255.255.128. The destination IP address is 192.168.1.130. After AND between these two IP address, we get an network ID. If the network ID is of class A, then the packet will go to the subnet A. If the network ID of a class B, then packet will go to the subnet B. For a given example 192.168.1.30, if we add, we get 192.168.1.128. This is the network ID of the class B. Hence the packet will go to the class B via path B. The routing table for the given example is as follows. This is the network ID of a subnet A, whereas this is the network ID of the subnet B, and the subnet mask for the both is same, as because we have only one subnet ID, one bit as a subnet ID and all bit as an host ID, network ID. Therefore, once in all network and subnet will be the same for the both subnets. This is an interface from which it passes A, and this is B. If any packet of any IP address ranging from 192.168.1.0 to 192.168.1.255 comes, it will first get AND operated with the subnet mask. It will give an IP address network. If it belongs to the network of 192.168.1.0, then it will passes through network interface A and goes into the subnet A. If the AND operation gives the network IP address of 192.168.1.128, then it passes to the interface B and goes to the subnet B. In this way, the given packet processes in subnet mask. This is all about the subnetting and subnet mask.